Hi guys, okay, I'm going to do one lesson where I just talk through each of the circle properties, the circle theorems, and then I have 3 more lessons where I just do past paper questions, which I think have covered, I think I've got like 8 questions, and it covers at least, it covers each of these at least once. So some of these are straightforward, others a bit more complicated. So first one, angles in semicircle is, angle in semicircle is 90. So if you get a semicircle anywhere, some of these are quite interesting, guys. If you get any semicircle like that, straight through the middle, that's the middle here, diameter, then this angle anywhere, no matter where you put it, it's always 90 degrees, the one at the circumference. So that one there will be 90, and it doesn't matter where you do it. Even if you did it like here, like right beside it, it's still, mine's slightly off, but that would be 90 degrees. Okay, next one, angles in the same segment are equal. So a segment, guys, is if you just draw a line across, I should probably use a different color here. If you draw a line across here, that is this is a segment and this is a segment. So as long as you start from the same points on the, basically at the end of the chord, you will always get the same angle. So here, this angle, if I start here, this angle here will also be the same as x. And then if you went the other way, this is now in a different this is in a different segment, but that angle there would equal that angle here. Like those two would be equal. Okay, next one. The angle at the center is twice the angle at the circumference. So again, if we come from the same note, guys, we are coming from the same 2 points on the circumference. If we go to the center and we go to the circumference, the center one's obviously bigger, but interestingly, it's exactly twice as big. I've also put this one in, guys, that sometimes people mess up. I'm still coming from the same point, but it's kind of backwards. But when I come to the center and when I come to the circumference, it's this angle that's double this one. So they're both kind of they're both on the same side of the two radiuses, if you like. So the x is here, the 2x is here, the x is here, the 2x is here. But just when it's drawn that way, just be clear, guys, that this one is double, this one is not. It's not that one. Okay, next one. Opposite angles in a cyclic quadrilateral add up to 180. So this plus this one and this one are 180. A cyclic quadrilateral, by the way, guys, is a quadrilateral four-sided shape on that is on the circle. So each corner is on the circle. That's what makes it a cyclic quadrilateral. And the opposite ones add up to 180. This plus this is 180. This plus this is 180. Okay, this one is one that often people forget, guys, is that the triangle with point at the center and circumference, triangles with points, with point at center and circumference, okay, so I guess points, that should say, is isosceles. Angles at circumference are equal. So that's kind of obvious because when you think about it, because they're both radiuses. So this is obviously an isosceles triangle. So these two angles are equal. Okay, next one. The radius and the tangent meet at 90 degrees. That kind of makes sense if you think of what a tangent is, but there you go. And if you think of a wheel of a bike moving along a road, the road and the center will be at right angles, if you like. Okay, this one, guys, is probably the most complicated or confusing one, or unrecognizable, or hardest to recognize in a question. So it's the alternate segment theorem. The angle between the tangent and a chord is equal to the angle subtended by the same chord in the alternate segment, right? So that x is equal to that x, and that y is equal to that y. Now, fair enough, guys, that wording is confusing. So what I always tell students to do at this point is to just draw one themselves. So there's a circle. You get a tangent anywhere. Just draw a tangent. There is a tangent. So that will meet that meets the circle at this one point. And then you draw a triangle anywhere from that point, but it has to touch the circle. Okay, so there's your tangent, there's your triangle. Then this angle here, equals this angle here. And if you want to think of it as this angle here equals this angle here, like that. It is the angle between the tangent and the chord. That's that's the tangent, that's the chord, that's the right angle. It's equal to the angle subtended by the chord. That means like from this chord here in the alternate segment, so over here, this guy here. Okay, that is the alternate segment theorem. I'll leave that there. This one, the radius through the midpoint of a chord bisects the chord at 90 degrees. So that's kind of obvious. If you have a chord, any chord here, and you draw a radius if you go through the midpoint, so go through the middle of that, it will cut it in half at 90 degrees. So I think that kind of makes sense. This one, tangents from their intersecting point have the same length. So tangent and tangent, when they meet, then that length here is equal to that length there. That kind of makes sense, but you will see that in questions, guys. You can kind of note that you'll get an isosceles triangle, or often that becomes like a quadrilateral that you have to deal with. That's 90 degrees, and that's 90 degrees, and things like that. Okay, this is the intersecting chord theorem. So when two chords intersect, a chord is just a line going from one side of a circle to another. And when they intersect, then the product of the lengths of the line segments on each chord are equal. So look, I've just written it here. A times B. This times, this times this equals this times this. That's all it means. A times B equals C times D. And then finally, the intersecting secant theorem is a bit more complicated. So when these two lines intersect, so secant, guys, is just a line that cuts through a curve, but in this case a circle. So a line that cuts through a circle and another line that cuts through the circle. And when they meet, then I've written it as A plus B times B equals C plus D times C. So people sometimes get this mixed up. It's the long one, this one, times this one. I'll just put it there. This one times this one equals, sorry, not all the way from there. This one times, give me another color, please. This one, like this. So A plus B, the big one, times B equals C plus D, the big one, times C. And that's it. Okay, so guys, those are the circle properties. As I said, I'm going to do 3 more videos with past paper style questions. Well, you need to know all these. You're not given any of these in any formula sheet or anything. You need to know them. So get learning.